Okay, we're going to look at the next question now, question 3. The time t seconds it takes for a water heater to boil is directly proportional to the mass. So T is directly proportional to the mass. So T, proportional, mass M. And we now introduce the constant of proportionality, T equals Km. And now we substitute in the data that's given that links M and T. So we get 600 equals K times 250. Divide both sides by 250, we get K equals 600 over 250. And if we cancel that down a little bit, we get 60 over 25, which is 12 fifths. So K equals 12 fifths. Okay, now once we've done that, we then substitute our value of K back into this equation here. So therefore, T equals 12 fifths times M. That's our equation that we're interested in. So that's what we write here. Now it says the time t seconds it takes a water heater to boil a constant mass of water is inversely proportional. So this is a different question now to the power. So we write our inverse proportionality statement. T is inversely proportional to the power. So then we write a proportionality statement, remembering that we have 1 over p. And now we introduce the constant of proportionality. Now we try and work out what K is. So we're going to use this data. So let's go up here now. So when T equals 360, this is K times 1 over 1,400. So K is 360 times 1,400, multiplying both sides by 1,400. Let's work out what that is. 360 times 1,400. That's 504 with 3 noughts, 504,000. Okay, so once we've done that, we're going to substitute that back into this equation here. So we get T equals 504,000 times 1 over P. Okay, and that's our answer to finding the relationship between T and P. Now we've got to answer the question. And the question is going to use this formula we just found. So find the value of T when P equals 900. So let's go here now. Let's go over here. Sorry, there's not much room here. So when P equals 900, T is 504,000 times 1 over 900. So if we do that on the calculator, we're going to get 504,000 and we'll divide that by 900. We'll get an answer of 560. And T is the number of seconds, so that's seconds. Okay, next question. D is proportional to S squared, so we write a proportionality statement. D is proportional to S squared. Introduce the constant. D equals KS squared. Use the data provided, which is here. So we get 900 equals K times 20 squared, which is 400. Divide both sides by 400 to get K. We get 9 over 4. 900 over 400 cancels down to 9 over 4. Once we do that, we substitute K back into here, so we get D equals 9 over 4 S squared. Now it asks us to answer the question. So calculate the value of D when S is 25. So when S is 25, D equals 9 quarters times 25 squared. Work that out. 9 quarters times 25, and we get 1406.25. Okay, next question. In a spring, the tension T is directly proportional to its extension. So here we go. T is directly proportional to its extension X. Introduce a constant of proportionality. Now use the data provided. So tension is 150. Is K times 6. So therefore K is 150 divided by 6. And 150 divided by 6, we can cancel that down. Divide top and bottom by 3, and we get 25. So k equals 25. And then we must substitute that back into this equation here. So therefore, t equals 25x. Once we've done that, we can write that in there. Calculate the tension, calculate T when x is 15. So when x is 15, T is 25 times 15. I'll do 25 times 15. $375. And it's newtons. Calculate the extension, in other words, calculate x when the tension is 600. So we're going to use this formula again that we found before, T equals 25x, and we want to calculate the value of x given that T is 600. So substitute in 600 for T. To find x, we divide both sides by 25. And if we do that, 600 divided by 25 goes in exactly 24 times. So x is 24 centimeters. Question 6. D is proportional to the square of t. So D is proportional to the square of t. Introduce a constant. Put in the data. 8t equals k times 4 squared, which is 16. Divide both sides by 16. We get 80 over 16. And simplify. 80 over 16. That's 5. So k is 5. Substitute k back into here. So we get D equals 5t squared. So that's the first bit answered. Work out the value of D when t equals 7. So when t equals 7, D equals 5 times t squared. So that's 7 squared. 7 squared is 49. So we get 49 times 5, which is 245. Work out the positive value of t when d equals 45. So again, we're going to use our formula, d equals 5t squared, and we want to find out when d is 45. So we get 45 is 5t squared. Divide both sides by 5. So we get 45 over 5 equals t squared, and 45 over 5 is 9. So we get t squared is 9. And if you square root, you must do plus or minus the square root of 9. So t is plus or minus 3, but it asks us the positive value, so therefore t equals the positive value of 3, so t equals 3. Distance d travelled by a particle is directly proportional to the square of the time, t squared. Introduce a constant, use some data. 40 squared is 1600. Divide both sides by 1600. 30 over 1600. Cancel down. Get 3 over 160. So k is 360. So we get d equals 3 over 160 times t squared. That's our answer for this. 3 over 160 times t squared. Calculate the value of d when t equals 64. So we've got d equals 3 over 160 times the value of t squared when t is 64, so 64 squared. And then the calculator, we've got 3 over 160 times 64, 3 over 160 times 64 squared. And we get 384 over 5. 384 over 5. Calculate the value of t when d equals 12. So we're going to get 12 is 3 over 160 times t squared. Multiplied by 160, we get 320 Divide both sides by 3.